Okay, welcome to the beginning Bioinformatics Part 3 walkthrough. If you haven't done it already, you'll need to download the Word file from Canvas, and we'll just go ahead and start walking through that. So in today's section, what we're going to do is learn how to write scripts. So running your first programs, and I will, excuse me, use programs and scripts basically interchangeably. There's historical reasons why you might make a distinction. Scripts typically from interpreted languages, whereas programs are from compiled languages, programming languages, I mean. But that distinction is not super important to what we're talking about, and I will use those two terms interchangeably. So first steps here, we're going to create a directory in our home directory to store all the programs that we write, or at least most of them, and we're going to call it bin. So some of you may already have a folder called bin, so one way to check, right? Let's list the contents. I opened a terminal. Let me blow up the text here so it's easier to see. And you can see I'm in my home directory here. So if I do ls, you can see all of the files that are in my home directory. And I do already have a bin folder. Okay, and some of you, depending on your system and what you've done there in the past, you may also have a bin folder. If you do not have a bin folder, you should create it. And remember, you can go back to the previous tutorials where we learned the command to make a directory, which is mkdir bin, right? And then you would hit enter. I don't want to do that because I already have a bin folder and I don't want to overwrite that. Okay. So if you don't have it, go ahead and create that bin folder, just mkdir bin. And then when you do ls, you should have a new folder, home directory called bin. So next step, we're going to cd into that folder. Okay. And we're going to create our first script. And it's kind of traditional to make a script that just reports hello world when you're learning a new programming language. So step one here, right? cd into the bin directory, which I've already done, and then create a new file using nano. So nano is the built-in text editor in Linux. And so we're going to invoke nano, and then we're also going to tell it the name of the file at the same time. So this is going to create a file called hello.sh and open it in nano. If you just type nano with no file name, it will create a blank document and it will wait until the end when you're closing it and ask you to name it. We'll see that when we close this. So this is what nano looks like. Blank document. You can see the name of the program here up in the top. So this is nano version 2.0.6. And the file name we're working on is hello.sh. And the first line here is called a shebang. So that hashtag exclamation point /bin /bash. That is telling it we're going to use the bash interpreter, which is sort of analogous to the Python interpreter when we start to use the Python programming language. So this is just telling the UNIX environment how to read this file or how to interpret this program. The next line 3 there. Oh, and also notice, right, don't type the numbers here, right? I just left those numbers in so that you can look at the lines as references here. So I could more easily say, okay, line 2 is just blank. Okay, so I'm not typing the numbers into Nano. Normally, any line that starts with a hashtag is, or the pound symbol, is a comment line. So we're telling the bash interpreter not to interpret this line, right? This is just for us to know the comments about what that section of code is going to do. And in this case, it's just saying this is my first UNIX shell script. Okay. Now, obviously, right, this also starts with the hashtag, and this is that first line in the program having the shebang is the only time when leading a line with hashtag doesn't mean comment. And then the last line, we're going to do echo hello world. Hell world, that would have been interesting. Okay. So once we've got all our text entered, Control X. So I'm down here on step 2, and I put a note to Mac users that it has to be the control key, not the command key. Okay. So Control X, and then I'm typing yes. So save the modified buffer, right? We want to save our changes. So hit Y, and then it says file name to write. And this is where I was saying, if I had just done Nano with no file name, it would be asking me to name the file here. But we have hello.sh as our file name, and we're just going to keep that file name. So we hit enter. That's step 4. Okay. So now if I do ls, so I have a few extra files in my bin folder from other work, but you can see I have this hello.sh. Okay. Now to run it, we just type hello.sh, and I got permission denied. All right. So looking at the tutorial, right, I expect it to not work. Okay, but don't worry, this is part of the learning process. So 2 common errors. The first one is the permission denied error that I just got. So how do we give ourselves permission? Okay. First of all, let's look at the permissions. So ls-l. And I gave a link here, or a pointer, to go back to the beginning Bioinformatics tutorial part 1. U13 talks about the ls command and how to understand what the -l is showing you. So that first column is showing me directory or file. If it's a dash, it's a file. So if we go over here to hello.sh, move this up a little bit. What I can see is that those first 3 are for the user, or the owner. And I have read and write privileges, but then there's a dash. So typically, well, not typically, that third column is for the executable permission. So this is the 3 read, write, executable for the user, for the group, and for everyone else or others. And you can see that nobody has executable permission for hello.sh. That's why I got the permission denied. I do not have permission to execute this file. Okay. So to fix that, we use the command chmod. And task 42.1 says add executable permission only for yourself. So if we go up here and look at the syntax, chmod, and then the first option is who do we want to assign permissions to? So in this case, just me would be the user, you, and then I want to add permission plus, and which type of permission, X. So u plus X says add executable permission for the user, and then I need to tell it which file. Okay, and then enter. So now if I do ls-l, you can see that it added the X for user control. Now try hello.sh, and it worked. Okay, now for some of you it still may not work. Okay, that's okay, we're going to get to that next. But yay, for those who it did work, you just wrote and executed your first program, at least for this class. All right, so for those that didn't work, one of the most common reasons, and I said there are two main reasons why your programs won't run. One is not having permission, and then the second one is not having the right path. So Unix isn't looking in the right place. So this capital $PATH is actually an environmental variable. So an environment in the sense of the environment of your terminal. And it tells Unix everywhere it should look for commands. If your commands are not in the path environment, Unix will give you a command not found error. Okay, because it can't see the file. So you know, obviously mine worked. I didn't get that error, but that's because I already have the bin in my path. So how do you look at the path? I'm sort of skipping ahead in the tutorial here, but I just want to show you. Right, my path to my bin folder. So echo path will let me look at everything included in my path environment, and you can see here users jp/bin is in my path. So Unix knew to look in the bin for commands. If you don't have the bin in your path, you'll get a command not found error. What's even weirder is if you have a command or a program like this in some other location than your bin directory, even if you're in that folder, Unix won't find it. So the other thing that besides, well, it won't look in the current directory by default. And so you can see in my path, I've also added that // so that, whoops, so that Unix will look in the current directory. So how do we make those things happen? Okay, I kind of skipped ahead here in the tutorial, so we're going to actually get to those in a second. But so we just did the echo path, okay, to see if you know, bin or current directory is in your current environment. Now, even if it worked for you a minute ago when we ran Hello World, it's worthwhile to sort of follow along with how to modify your path, because there will be times in the future where you might want to add some other directory because you're going to store programs in something that's say in the same directory with your data. Okay, and then you might want to add that directory to your path so that Unix recognizes commands that are saved someplace else. So even if it worked, don't skip this section. I try to make this as bold as I can. A few of you have already asked me questions and run into some issues with file names that were already on your computer that have spaces in them. Okay, Unix hates spaces in file names. Okay, so avoid it if you can. You'll see lots of my file names and directory names have either dashes or underscores. That's because there's no doubt it's easier to read things if they have the spaces in there. So instead of having a space, I put a dash or an underscore just to make file names understandable, but also easy to use in Unix programs or from the command line generally. And then the second point here about extensions, we saved that hello file with a .sh because the extension, the stuff that comes after the period in a file name is meaningful. Okay. And in this case, it tells me that hello.sh is a shell script. Later, when we start doing Python programming, we'll give it the .py extension to tell us that it's a Python file. Now, that said, I could, if right, the computer doesn't necessarily care, other than it will by default try to run it with the extension that's assigned to a particular program. Okay. Okay, so if we had a path problem, so we got the command not found error, there are two temporary ways that you could fix that. So I'm actually going to break. Let me break my path. Oops. I'm going to show you in a few minutes how to modify your profile. That's the, I think, U45. But let me break this for a second. It didn't break. I'm going to try a new terminal, try reset my terminal here. There we go. So that I'm not sure what happened. We'll talk about source in a few minutes, but stopping and restarting my terminal forced that to reread my configuration file. Again, getting ahead of myself a little bit. But now, when I did echo path, you can see some of that stuff that I had added, like the user is not there anymore, right? My jpdaemon bin is not in my path. So some of you may see this by default. So if I cd to my bin directory, and now if I do hello.sh, I get the command not found error, okay? So there are a couple ways I can fix that. And just to show you, right, hello.sh is still there. This is what I meant by Unix doesn't even know to look in the current directory for that program. So I can fix that, right? Task 44, if I combine that with look in the current directory, right? The / means in this directory. hello.sh, it works, right? Because I forced UNIX to look in the current directory with that /. Okay. So that is one of the temporary ways to avoid the command not found problem. You just specify the path along with the command, and then it fixes it for that command line, right? It doesn't modify your path environment. It just tells UNIX where the command is, okay? The second way is to modify your path for the current terminal session. So I could do export path equals the current path environment, and then I'm going to use a colon to add on or separate everything that I want to add to the path. So I'm going to add the current directory to the path. Okay, so I'm right here in the tutorial. Now, if I do echo path, to look at my path environment, you can see on the end here, right, it has all that default stuff from originally, but now it has added current directory to the path environment. So let me try running hello.sh, right, and it worked. I didn't have to force it to look in the current directory because I've added the current directory to my path environment. Okay. Now, in this instance, I also don't have my bin in my path environment. So this method of, export, actually, let me just tab up, right? So I could use that same command to add my bin folder. That's the next task down here. And I hit enter. And now if I do echo path, you'll see, right? Now I've still got that added, and now I added a new one. Okay, and notice I gave it the relative path, the tilde, right? Remember that represents my home directory /bin, and the path environment actually holds the absolute path. Okay, yours may look different depending on if you're on a Windows machine, right? You might have that mnt/c/users and so on. Okay, but it has added my personal bin directory to the path. Okay. Now, the problem with that, or not really a problem. So there are instances where you might want to only modify your path environment for the current terminal session. But the downside is that if you always want the current directory and your bin folder in the path, this isn't going to do it, because if I close my terminal, open a new one, and echo path, you can see they're gone, right? I don't have current directory or bin in there anymore. And if I cd over to bin and do hello world, whoops, hello sh, I get command not found. And yet, there it is right there. Okay. And interesting, right? I can do less hello, and I can read it, right? It's just that UNIX can't recognize it as a command if it's not in the path environment, or if I haven't specified the path. Okay. A word of caution here in the middle, the bright red, is that when you're doing that export command, never forget to include the current path. So the current path is the $ path. The $ says this is an environmental variable. Okay. And the reason for that is if, for example, I did this, and I forgot to put the $ path, this is going to erase my whole path. And so now Unix will only look in, I'll show you. Don't do this. This is me breaking it. All right, so my path is only that. So now I wonder if this will even work. Yeah. So things like what that did is Bash can't even recognize what the ls command does now, because it doesn't have user local bin, user bin, all of these root level or Linux wide levels of bin. Okay, I talked about, I didn't mention that, but up at the top, when I said make that bin folder, there are multiple bin folders at different levels in the directory hierarchy in Linux. So things that, like at the root, have commands that you need basically across the whole operating system. Okay. When we erase the path, it no longer looks in these files that are sort of globally useful. And so I've lost the ls command because my path got erased. Okay. The good news is I should be able to do hello.sh because it should look in the current directory. Yay. So I can't list directories, but I can run my hello world program. Okay, so I want my path back, so I'm going to close that terminal and start a new one. Right, that's the upside of using export from the command line to only modify that terminal environment. Because now I closed it and got a new, and see my path is back to the default. Okay. All right. So those are the two ways to temporarily sort of run commands. The first one, specify the path. Second one, use export to modify the path environment for that session. But then the more permanent way around the path problem is to modify your configuration file. And so that's what I was talking about earlier, or not talking about, but I went in and broke in my .profile file. That is the configuration file for my terminal environment. So just some background here on configuration files. There are multiple different ones sort of scattered throughout those bin directories often, or at least just like the bin directories. And these are files that are well, not typically, again, they're always hidden. And so if I want to see them, I have to do ls-a to list all files. And because I've got so many files in my home directory, the hidden files are always listed first. So if I scroll up, actually a better way to do this, just in case, yeah, let me show a better way to do this would be ls-a and then pipe that into less. So now I get my output one screen at a time. And you can see everything that starts with a dot is hidden. And configuration files will have something like profile in them. So I've got a profile here for conda bash, which is just a package manager you don't need to know about yet. Let me keep going down. Okay, here is my .profile, and some of you may already have a file like that. Some may not. Some may have. Did I have it here? Yeah. So at this point, I only have 2 of those profile files. And there are other files that are commonly used as configuration files. And if after you've done this a while, you'll run across them over time. But we don't need them at this point. What I'm hoping is that this is going to work across the Ubuntu that the Windows users are using and what the Mac users are using. If you run into problems with it not reading the .profile, we may have to figure out what your system wants the configuration file to be called. But for this example, we're just going to stick with .profile. I debated on how deep to get into what is a shell. I am running. Come on. The bash shell. By default, Mac users, you may be in Z shell. Really, these are interpreters for Linux. So they sort of sit behind the between the machine language, which is the real binary code that your computer understands, and the scripts or the programs that are human readable. Just like what we wrote to tell the computer to say hello world. Well, the computer doesn't literally understand the words echo hello world. Okay. Bash is the interpreter in between that sort of English language version and telling the computer, right, your CPU, what to do when it sees that. Okay. And there are other flavors. Z shell is the new default for Mac. Ubuntu is probably, I'm pretty sure, even the latest version is defaulting to Bash. Z shell and Bash are very similar. The differences are not going to be important. And usually the differences pop up in all kinds of quirky little ways. But it's good to know which shell you are running, just in case I give an example and you're using a different shell and something odd happens. Well, everything may seem odd that doesn't go correctly, but it is one potential difference if you're running a different shell. But since most of us are using Bash, and the differences between Bash and Z shell are really small, hopefully everything works the way I'm showing in the examples. Okay, so that was a long aside to the permanent way we're going to fix this path problem is to modify the dot profile. So I'm going to do nano dot profile. And if you don't have a dot profile, this is going to create it, just like the hello.sh was created when we did nano. If you do already have a dot profile, nano.profile is just going to open that file. So you've seen this earlier. When I do nano.profile, I already have a whole bunch of stuff in my profile. Okay. And down here, this is where I went ahead and broke it. And I've added a bunch of other stuff. So you don't have to worry about this Conda one. Right, I'll leave that commented out. So by putting a hashtag, just like in the hello.world, just like in a regular program, I'm saying, don't read this line, okay? Because as a profile, I also don't need to have the shebang at the beginning. But other than that, it is very similar to writing a program in terms of the vocabulary. But what you should be writing here is export path equals, always remember, leave the current path in there, okay? And then whatever you want to add. So in our case, we'll add, whoops, those two things. Okay, now exit, Control X, save it, and don't change the file name. Oh, I skipped over a very important step. If you already have a .profile, it's always a good idea to make a copy. If you followed along there, hopefully, if you already had a .profile, hopefully you didn't just mess that up. If you did, we can fix it. Oops. Anyway, it's a good idea to just make a copy if you already had a .profile and you're worried about messing up something in your environment. You can do a copy .profile to .original profile, and then you'll have both of those files and you can work on just this one. Okay. For most of you, that's probably not an issue. And then I also had, if the bin, your personal bin folder was listed in your path already, you can add just the current directory, the // and if bin was not in your directory, in your path environment, then add both the current directory and bin. Okay, so the example I showed, right? So I am adding both. And now if I do, just to show you echo path, see, neither one of those is added yet. And that's because the terminal hasn't had an opportunity to read my profile yet. So this is where this is a little bit odd that this didn't work earlier, but so I do source, which tells Linux to read my profile. And now if I do echo path, so this time it worked fine. I'm not sure what happened last time. So see how, okay, I had written or edited my profile to add current directory and the bin folder. Then I did echo path and see they're not listed. Then I told Linux using source to read that file again. Then I did echo path and I see that now that new edited profile has been read and those things have been added to my path environment. Except I see a mistake. This is not going to be read. But tilde bin needs a slash in it. So I need, yes, so that's my typo. Hopefully you recognize that before you made it. Control X, save. Source, echo. Oh, that's interesting. Now I see why. Well, for better or worse, I'm learning something during this video too. So what happened? I do see why. So it did add the current directory and the bin. So now I have those added, but I never would have noticed this without my typo mistake here. And it's kind of interesting. It's always good to think about when you get something unexpected. It's good to think about how did that happen? Well, what's happening here is every time it exports path, it is using what's in the current path and adding the new stuff. And so the first time I ran this, I had a typo there. But that typo is staying in the path environment and just adding the new stuff when I use source. Okay. That's kind of cool. Except we don't really want that to happen. It's interesting just because of knowing how the shell works. But to get rid of that typo in the path, if I close my terminal window now and reopen it, now whenever you open a new terminal window, that profile should be read for the first time. And because now the shell has never seen that typo version, right? Because it's reading the corrected path only, the corrected profile. Now when I do echo path, right, the typo is no longer there. I've got that default stuff, and that default stuff is specified in a profile someplace else, like one of the other bin folders higher up. So because that generic or default path to go look for UNIX commands, you want that specified for everybody who uses the machine. So that's going to be common to any users who have accounts. Okay, it's just that // in my personal bin that got added from my personal profile. Okay, and they're corrected this time. Okay, so that's pretty cool. And also notice, right, even though this is permanent, which anything you're doing to modify environmental variables on sort of a permanent basis can be, it can cause problems. In number one, if you accidentally put typos in here that change the higher level path, so it no longer could read ls and things like that we saw in the temporary version. Okay, that could make it difficult to fix the profile, but there's always a way to reset it, so you don't have to worry too much. Okay, so now every time you open your terminal, you should have those changes. And then one other useful thing that I wanted to point out, as long as we're on the topic of modifying your environment by editing the .profile, is that we can, and you have already saw some of them in my profile. So I'm going to now put my profile back to normal. U46 is adding aliases. So you can see I have a bunch of them listed. And it's really a way to create a shortcut. So for example, in my profile, Raven and Crow are the names of two of the servers in my lab. And so rather than type out this whole long command, whenever I want to SSH or connect to that computer in my lab, I can just type Raven and know that I'm going to connect. Okay, same. We'll look at these later, and you can always come back if you want to know how to add these SSH commands. But really, the syntax for creating an alias is easy. You just type alias, and then whatever you want the shortcut to be. In this case, LL equals And then in quotes, you want to put the keystrokes that you want LL to actually do. So in this case, I want it to do ls-l. The capital G is to colorize the output. I'll show you in a second. There are a ton of options for ls, and you could create your own shortcuts if you want. But I'll show you how these work in a second. So these are examples where, I created a shortcut so that I wouldn't have to type in a really long command, or aliases for commands that are really common. So this isn't a really long command, but rather than type ls space -l, I can just do ll and get the same output. And I added the G because sometimes it's nice to be able to see which ones are directories just by their color. Okay. So I'm going to save this. X, save, S, and keep it as a profile. Now that I know source profile just builds on the path, I'm going to use that less often, but it'll be fine in this case. So some of you have seen me already in the tutorial using things like LL, and see how it gives me the output for ls-l. Right? I'm getting all of the directory permission information, the size, and all that stuff. If I do LA, it's the same thing as ls space -a, right? So I can see my hidden files. And I had forgotten that I specified LAL. Whoops, is it LLA? Whoops. Oh, there we go. I forgot the shortcut. So I did LLA. I'm going to pipe that into less just so you can see that it's giving me the outputs for ls space -la. So I'm seeing the hidden files, and I'm seeing in this list format where I get the permission information and everything. Okay, and you can make those for pretty much anything you wanted. So I said I would show you there are lots of. Oh, and also see how it colors my directories blue. That's what the capital G did. So if you look at the manual page for ls, you'll see there are lots of options. All right, so the A we've used before. Right. So that's to list the long format. This is the other one, enable colorized output. Okay. So lots of things that you might add to the ls command that make it more useful for different things. And then if you want to build shortcuts in your profile, you can. Okay, so now let's actually write a script that does some useful stuff. So I'm going to make sure I go to cd to my bin directory. So I'm in the bin. Oh, and I'm going to, before I do that, so I'll do less. I don't need to edit it. I was going to show you, a couple people asked me about my command prompt. This last line in my .profile, if you copy that, I don't have this in the tutorial because it's not super important that your command line looks just like mine. And you can Google how to modify the command line in Linux and see what some of the terminology is. But this, what looks like, you know, not very readable. PS1 is the command prompt, and it equals, and then this is how I've specified. It's basically the user and the machine name, and in brackets the current working directory, and then it gives a space. So you can make the command line look at like whatever you want it to. Okay, just I'd forgotten. I'd been asked about that a couple times, so that's how you can change. Right, I've got username at the machine name, and then in brackets I can always see what my current working directory is. So I'm in the bin folder, and I'm going to create nano cleanup.sh, and then write. So hopefully you recognize what this program or script is going to do. Right? By just thinking about, right, we've seen these commands before. If I entered any one of these commands at the command line, it's saying move a file with any name .text, right? The asterisk on the file name search is match any characters. It was another thing that people have asked me about on the ACGT thing. The asterisk on the command line when you're searching or specifying file names means something slightly different than when you're using it in a regular expression like grep, right? Grep has a slightly different use where you have to use the dot to represent any character, but the dot means any character one time. And then the asterisk means any number of times, including 0. So if you do dot asterisk, it means match any character 0 or more times. So AC asterisk means match the C any number of times, including 0. Whereas AC dot asterisk means have an AC and then match any characters any number of times, including 0. Okay. In this context, right, the star means any characters any number of times. It's going to match all file names, right? Because this is not grep. This is not a regular expression. It's just a wildcard character. And it doesn't matter how many occurrences there are. And so it's saying move all the files that have .txt into text. And similar for JPEG, MP3, and FA. Okay, so it's basically saying move all the files with a certain extension into sort of a corresponding folder or directory. So I'm going to do Control X, Y to save, and keep that cleanup.sh name. Now the next task is to run that on the data test file directory. Okay, so I need to move over to that folder. You remember where it is. So it's in my home directory. So cd data UNIX test files. And if I do ls, actually let me do ll, make it a little easier to read. Okay. So you can see I've got music, pictures, sequences, and text. Those are the directories. And then I've got a bunch of files with those extensions from the cleanup program that we wrote. So I'm going to do cleanup. Whoops. That's not going to work. I already know it's not going to work because I did that and then I hit tab. Whoops. I did that and it hit tab. So that was double tab. And those clear, clang++, and clang, those are commands that exist somewhere in my path. Cleanup.sh is not in my path somewhere. So that's interesting. That tells me that already I either have permission problem or path problem. My path is looking in, stretch it out here, right? So bin is in my path. So it shouldn't be a path problem. Let's go back to I'm going to go back to my bin, do LL. Oh, and indeed, forgot to give it executable permission. So chmod u+x. Do LL again. And also, I mean, this is another reason why the the capital G option can be useful, right? Because I can see when things are executable for me. It colors them differently. Like if I give everyone executable permission for that. Oh, I guess not on this one. So by not specifying user, group, or other, I gave everyone executable permission, all three of the. But two of them don't have write permission. What if I give everyone write permission? Oh, that's strange. It did not add. Interesting. If you have questions about what I was doing there, feel free to ask during office hours or during in-person class. But in any case, I just wanted to show what it looks like with all of the permissions on for everyone. Okay. And you can also remove chmod can be used to remove. So I just removed read and write privileges for group and other, but it retained read and write for me. That would be kind of weird. The numbers that I used, if you do man on chmod, you'll see that you can specify read, write, and execute based on a number system. 7 means give read, write, and execute. Okay, I'll leave it there because we should be able to execute it now, and I'm going to cd back to where our data are. Okay. Now, if I do, okay, my tab actually was able to complete cleanup.sh, so I hit enter. Nothing happened. I didn't get any errors. So now if I do ll again, oh, all the files are gone. Where did they go? Actually, I don't need a cd. I'm just going to do ls music. And if in my music folder, song 1 and song 2 moved over there. So my cleanup script worked. It moved everything with the FA extension into the sequences folder. It moved everything with MP3 into the music folder. And you might think, why in the world is this useful? For shells, you know, I said this was going to be a useful or a more useful Unix shell script. Well, there's lots of software in bioinformatics that will create intermediate files, and some analyses just generate lots and lots of output files. And so you'll get these directories that are, you know, could be hundreds, thousands of files, and this script could be modified pretty easily to, say, take all of the files that have a certain prefix because you know they belong to one species instead of another, and then move them into a file that is only for the output of that species. So a way to organize loads and loads of output analysis files. So potentially useful. Now, the last example is to create a script that will take some arguments. And we've already seen these in some of the what arguments are in some of the built-in Linux programs. But we're going to take one where we change the file extension from one argument to another argument. Okay. So let's go back to our bin folder where we keep all our programs. And nano change file extension. So I created a new file called change file extension. That's what this program is going to do. Add my shebang. For file name in, and I'll walk through what these lines mean in a minute. Whoops. Again, I'm not putting in the numbers, right? The numbers are just there for reference. That looks like a huge move, but it's just a single tab. Sorry, not following my own instructions. Jumped across lines. Okay, so assuming I don't have any typos, I'm going to exit. Yes. Keep the file name. And I'm going to go into the text directory here and try to run that command. Okay, well, before I go, won't not forget again this time, right? I need to do chmod. Okay, so it has executable permission. Now I'm going to go to text directory. If I look in here, I've got 3 folders, and let's just follow the instructions and do change file. So I hit tab and it completed, so I know that it's in my path and it's being recognized as a command. And I want to change txt to text. Okay, so I'm right here. Don't mix capitals in there. I don't know why I did that. Okay. Hit enter. Okay, no errors. And see how it changed my file extensions from txt to text. So if we look back at what this program does, okay, we've already talked about that's the shebang. For it starts a loop, and it's going to get every file name that matches this expression, which is just like from the previous one, right? When you use the star in a command line like this, it's just the wildcard, so it's matching any file name with a dot, and then the $sign specifies an argument from the command line. So this is saying the first argument. Okay, in our command line, txt was the first argument. So this is going to match each file name that ends in txt. And then it says do, okay, and we're in this for loop. Remember, to rename something, it's just move from one file name to another file name. So in this case, on the first loop through over here, it gets readme.txt because that matches this pattern, readme dot, and then our first argument is txt. And it moves readme.txt to this thing. So this says take the file name, and this percent says match at the end of whatever this variable is. So match txt at the end of the file name. And the percent also is going to strip that from the end. So this whole thing in brackets, and the reason it's in these curly braces is so that it will execute that before it does the stuff on the outside. So take the file name, strip off the end, and then now it's adding the second argument, which is text. So it should take filename.txt and substitute it with a file name, strip off txt, and add text. Okay, and then we just end the loop by doing done, and then it will go get the next file name. And if you look at the output, that is pretty much what happened. It took readme.txt and changed to readme.text. Task 48.2, use that same script. So modify it so that rather than, you don't have to modify the script. You modify the execution, right? Modify this line so that it changes these DNA folders that end in .fa, and you want them to end in FastA. Okay. So that shouldn't be too hard, right? I'm hitting my up arrow to go back here. And I want to change FA to FastA. Ta-da! Again, can be super useful when you've got lots and lots of folders. This is one where this kind of thing can be tricky or painstakingly long and difficult. If you were having to do this from Windows or Mac, for example, like off the top of my head, I would not know how to do that on Mac, right? How could I mean, you may know, there's probably a way to go into one of my big folders of FastA and say I needed to change the extension to just FA because the software I got to do my analysis requires the extension to be FA. This would be a super fast and easy way to almost instantly rename all of those files. So that's almost it. The last thing in the part 3 is job control commands. Sometimes you'll write a program that seems like it's taking too long, and maybe you wrote the loop wrong, and so it's basically just stuck. And so it's important to know how to cancel or otherwise control what's going on in your terminal. So right now, I shouldn't have any jobs running. So jobs is the first one. Okay, I got a blank, so there's nothing running. PS will give the process ID number, which I'll get to in a second. Let's just look at top. So this is basically telling me everything that's running on my computer right now. The process ID that I just mentioned, if you do PS, is that thing on the left-hand side. And there's a lot of information up here about, how many processes are running. So this is with me not having any quote unquote jobs running. This is just all background stuff that the various windows and programs that I have open are sort of running in the background. Oh, that's Microsoft Teams taking up 77% of my CPU. Okay, and 270 megabytes of memory. So that tells you what's running on your computer. And again, this can be important because if you start running a program and your computer seems to freeze, or if you're running things in the background, which I'll show you in a minute, you may not know if it's actually working or not, especially if you don't get the command prompt back. It's hard to tell what's going on, and so you can use top, and it will show you the name of the command and then how much computer resource it's using up. It's like the activity monitor that's built into Mac and Windows. Or task, I think Windows is Task Manager. Okay, so I just type Q to exit that, just like less. Okay. Just another note. This is more important when you move to cloud computing resources, where you'll have the processes from all the users being listed. But I could use top-user JPDaemon just to look at, whoops, what did I miss? capital U. That's in. I'm not sure why that did that. I'm sure lowercase u works in some instances. So now these, especially on a shared system, this would only be showing you the processes that were initiated by my user account. It's interesting. Oh, I know. So this must have changed in a recent version of the Mac. Bash shell, I'm thinking, maybe. Yeah. So if you can use just -u lowercase, and it's going to default to show you only the currently logged in user. So this should show me the same thing as that, but I have to use capital U with that. I'd be curious to know if that works on the Linux version of Bash. Also curious what happened in Z shell when they updated that, but in any case, it's a way to look at the current user. So let me start less on, let's see, where am I? I'm in sequences. I need to go. Just, it doesn't really matter. I'm just looking for a file to open up. So let's do less on my subset file. Okay, so this is the subset of the GFF that we created a few, actually it must have been in part 2. But, whoops. The reason I opened it is right now, Les has control of my terminal. I have those, that colon there, you can hit spacebar. So Les is running and it has control. I can do Control Z. So I just hit the Control Z button. And again, for Mac users, that is Control, not Command. And it tells me that it stopped the less command on subset. So it stopped what I was doing. Now, if I do jobs, I can see that I still have that job stopped. It didn't totally exit that job. It has just stopped it and sort of given me back the command prompt. If I want less to start going again, I can do BG for background, and it will start less in the background. Maybe less is not the best example. So I got less, so it sent less to the background. That little and symbol is a way to send things automatically to the background. I'll show you in a second. But then it said it stopped. I'm not sure why. Oh, because less stops after every, when it's in the background, it stops after every page. Okay. If I do foreground, it brings less back to the front. So let me do Control Z again to stop it. And now I'm going to do less on the chromosome 1 file. So this one's huge. I'm going to do Control Z, so I stop that. Now if I do jobs, now I've got 2 of them running. Right. Now, the plus minus, if I just do foreground, the one that has the plus is going to come to the foreground. Okay, Control Z to stop it again. But what if I want to bring the subset file to the foreground? I can do foreground %1. Wait, actually, just to check, let's do jobs. Okay, and in brackets, it tells me the job number. So I'll do foreground %1, and see now it brought back the subset GFF file. So Control Z to stop it again. Now I've still got those in the background. If I want to end it from here, I can do kill %1. And now instead of stopped, it says terminated. So if I do jobs again, now subset is gone, right? It now has totally exited that instance of less. And I still have this less chromosome 1 sitting in the background. I'm going to do foreground. Cancel. What if I do top? I wonder how much resource that takes up in the background. Actually, let's start it running in the background. And now do top. So less doesn't take up very much. It's not even showing. Probably because, I mean, it's one of the great things about less is that it gets to the end of the page and then stops. So it's not taking up any resources really. So Q to quit that. Should be taking up some resource though. Well, you can see that top is actually taking up resources, but less is not showing up. And I'm not sure why. I guess maybe it's so low when it stopped in the background. So I'm going to do Q. You can do the same thing with top as well. So I can do top and then Control Z, and it stopped top. So now I'll have top among my jobs. Let's kill that one. So terminated that chromosome 1 version of less. So now I have 2 versions of top running. And I mentioned a minute ago that ampersand, the and symbol, will send commands straight to the background. So if there's something that you know is going to take a long time to run, it might be a good idea to just start it out in the background. And it told me the process number and the job number. So now if I do jobs, I should have 3 running. And this isn't in the, so that's basically I've covered everything. Oh, except let's bring one of those to the foreground. And if I do Control C, that kills it and gets rid of it. So that Control C sends the termination signal. Rather than having to suspend something and then kill it, you can just do Control C. And see, now I only have 2 versions of top running. And then what I was starting to say is I can do, I think it's kill all. Yeah, I don't remember off the top of my head. Oh. Again, this is just sort of bonus content. -9 is the kill signal. Oh, it didn't. Interesting. Well, if I want to kill them one at a time, kill 3 and kill 4. And now I should have no jobs. Very strange. I wonder if top doesn't work that way. So let me try. All right, so we'll suspend that. So now my jobs, I added less. If I kill %5, that's the termination signal. And it's really strange that the termination signal does not work for top. Oh. Distracted. Huh. Yeah, it doesn't seem to work for top. That's what I get for trying new stuff on the fly. So I'm just gonna bring these to the foreground, maybe. Very strange. Very strange. What I think happened is I had sent the kill signal to those top jobs, and when I brought them to the foreground, they ended. So, right, this foreground, just returning the word top, that is strange behavior. But then it told me that that job didn't exist anymore. And when I did jobs, there's nothing listed. Okay. Interesting. But in any case, that was basics, and it should work for most programs. In what we're doing so far, we're not writing too many loops that are going to give you problems. So these job control commands are just if something goes wrong, especially Control Z and Control C can be used to exit out of something if you're not sure how to get back to the command prompt. And that's it for Unix. The next tutorial, we're going to start Python, but just a quick summary of all the commands that you should be familiar with at this point. Make sure, and I tried to sort of build, right? We used ls a bunch today. And try to sort of build up your vocabulary. There is a lot more that we could learn, but you can do some pretty powerful stuff just with understanding the how to use the commands that are listed here. All right, that's it for part 3.